Hello everybody, it's Mark Keane here. We're here again at Microsoft in North Ryde with Stephane Budo. And we're here for another whiteboard demystifying video session or video, whatever you want to call it. And this time it's for the Azure Firewall. Steph, talk to us. Azure Firewall, what is it?
Azure, oh geez, okay. So, hi. Azure Firewall. Now, before we get started in Azure Firewall, let's get through a few basic concepts, if you don't mind first, which is going to help later with the explanation of Azure Firewall. So the first one is, we probably all heard about the Aussie model. We're not going to spend much time on that, but it's important to the latest. Yeah,
not the
OSI. Yeah, that's right, OSI model. So back when people created the TCP/IP protocol, it's all based on a reference model called the OSI model, which is composed of layers. Now, when two applications need to talk to each other via the network, what that layer model will apply is effectively the packets will go through the model down, through the layers down, on the wire, and then back up to the application. So those layers are effectively 7 layers.
Which order does it go down and back up?
It depends which is transmitting. So when an application transmits, it goes down, and it arrives on the other side, it goes up, basically,
so
through the layers.
So down 7 to 1 and
that's
up
right,
1 to 7.
Exactly. Spend 1, 2, 3, 4, 5, 6, and 7. Right, at the lower layer, we've got the physical layer. So that layer will effectively transmit everything over the wire. Right, that's what that layer is responsible for. Then we've got the data link layer. So this is your layer 1, your layer 2. That's your typical MAC addresses.
So,
right? When we talk about switches.
So put that in context to express route, for example, or a fiber connection.
Okay, yeah, that's a good point.
So scenario based.
Your layer 1 is your fiber optic cable. Right, easy. So that comes into your switchboards and that's your layer 1. Your layer 2, your data link layer, is what we spoke about in those wonderful Express Routes Demystified video. Recommended.
So we're talking about layer 2 stretched VLANs and...
That's right. So layer 2 is where VLAN comes into play.
Cool. And
MAC addresses. So you've got your layer 2. This is where your switches are talking. Right? So this is the data link layer, which is your MAC address, VLAN, etc., etc. Right? Layer 3, which is your network layer. This is where we start to introduce the IP address, which goes on top of your MAC address. When an application will start talking, you'll get assigned a TCP an IP address. The transport layer, which is layer 4, this is where all your connectivity starts. TCP and UDP. TCP being a connection-oriented, UDP is being a connection-less, so no connection, so for DNS, etc., etc. Then the last 3 are often referred as the application layer, but are divided into the session layer, the presentation layer, and the application layer. So these high level are effectively what the application will start using. So, for example, the session layer is effectively making sure that all your session data the connection data going through TCP will be established and killed cleanly, etc., etc. Your presentation layer, this is where compression will happen, for example, on packets. This is also where the language that the application talks is converted potentially so that it can talk properly on the network. And the application layer is where your application is going to interface with the network. So this is really the point of entry for your application to start sending and receiving packets. So when you have 2 computers, on the other side, an application, the packet will go down the layers on the physical wire, and then on the other side it will go up the layers on the physical wire.
Okay.
That's the Aussie model. So when we talk about layers, and we say, oh, this particular appliance is a layer 3 device, this particular appliance is a layer 7 device, this is what we're referring to, those layers of the OSI model. Yeah. So a switch is a layer 2 device. A router is a layer 3 device. A firewall can be a layer 3 device all the way up to a layer 7 device.
Where does BGP fit in?
BGP fits in right here at the IP layer. Okay. Now BGP is not a routing, it's a routing protocol. It's not a routed protocol. So not to go into more details, but IP is a routed protocol, right? While BGP is a routing protocol,
Gotcha.
which takes care of routing. So that's the OSI model in a nutshell. Now, if you want more information, there's plenty of information on good old bing.com. Just go OSI model, and you'll see all that explained in more details. But for today's presentation, this is quite important because we're going to talk about those layers. All right, now, moving on to in Azure and networking in Azure, you've got the basic security and the basic routing definitions. So the first thing that we need to understand is what an NSG is, Network Security Group. And where does that work? Here. So a basic NSG is effectively just a filtering on layer 3 and layer 4, whereby you can say, I'm going to allow in or out of my network a certain IP address or a certain port on that IP address, TCP port and an IP address on layer 3 or layer 4. That's what an NSG is. That's it. For those who are more familiar with the on-premises networking, it's effectively an ACL. So yes, TCP on layer 4 and IP on layer 3, MAC on layer 2. Okay, so NSGs all there, 3 and 4. Fantastic. Now, when we talk about UDRs, user-defined routes in Azure, again, a basic principle is to translate that to the on-premises world, they are static routes. Okay, everything in Azure uses BGP in terms of protocol, in terms of routing protocols to determine what the best route is. But you can introduce UDRs and static routes if you want to. And this is where, when you introduce a firewall within those Azure environments, the UDR becomes really interesting because you can establish a specific route to go to your firewall, potentially to send all your traffic, the default route 000, for example. But we'll come to that in a minute. So that's UDRs. Okay, so user-defined routes. Again, the equivalent of static routes, go on Bing, UDR, NSG, very important. Okay, now, we got those basic components in place. Now, how do you do security in Azure? Well, the basic security is back to the NSG. So you do some ACL, some filtering on IP and TCP ports. So for example, when you deploy a virtual machine, by default, 3389 has to be open. NSG is very important there because you don't want people to get in, so you establish an NSG to say, I can only get in on 3389 from my specific IP address. That's a typical example of an NSG. Now, you can introduce, for more complex security layers, you can introduce what we call an NVA. Now, an NVA is effectively a network virtual appliance, which all your favorite supplier will supply in Azure today as a virtual appliance, and you can get firewalls as well. So all the big names are there, the Palo Altos, the Barracudas, the WatchGuards, they're all there. So you can use an NVA in Azure to increase that security all the way up to the 7th layer, okay? So for example, if you want to do some FQDN filtering and you want to say, well, this specific website, HTTP Facebook, for example, I don't want that to be accessible, so let's just block it.
You mean person.
Oh, you mean. Or, I'm all about work, mate. Or you can say whitelisting and say, well, Facebook, we're going to allow that. We're going to deny everything except for Facebook.
Or you can deny Facebook and allow Microsoft.
And allow Microsoft, that's right, exactly right. So this is what the application layer, the 5, 6, and 7th layer will allow you to do, and this is where those firewall comes into play, right? You can't do that natively without the Azure network construct. You need a firewall, an appliance to do that for you. So this is what those providers will provide to you at a cost. Now, one of the things about this is that all those appliances run on IaaS. Right? They run within a virtual machine, Linux or Windows, whatever the appliance is, which means that in order to run them appropriately, you need dual appliances. right? So you're not only going to pay for the licensing to use the third-party product, but you're also going to pay for the compute of 2 virtual machines
HA,
to run together.
high availability.
Exactly right. You can run them on one, but then, with the rules of the SLAs in place right now in Azure, that means that you're down to 99.95, I believe, for a single VM. So
no, 99.9.
99.9?
Yeah.
Okay. So dual VM is where you need to be, right? So cost. Think about that for a minute. Now, what has Microsoft done so far? They've introduced a new pass, which is Azure Firewall. Azure Firewall is effectively what those third-party providers will provide, but as part of the platform. So you can now have a highly available firewall services within the Azure platform for you. It does most of the things that an NVA will do for you, that a third-party firewall will do for you. So for example, those FQDN, it will do what, TCP/IP filtering. So it will literally say, you can allow this IP to go to this, through this port, to go to this website, for example, as an example. So Azure Firewall, fantastic new feature. How do you deploy an Azure Firewall in Azure? Well, the classical topology of an Azure Firewall is effectively to have a hub and spoke methodology. What's a hub and spoke is you create a specific VNet with the firewall in there. And then from there you create peerings to all your other VNets. And this VNet becomes your main central point where all your traffic will flow in and out of. This is where your firewall sits. This is back to on-prem for these hybrid environments. And so all the traffic will flow in and out of this and through there, through your firewall. Now, as we spoke earlier, this is where the UDR becomes critical, right? Because by default, if you create peerings between all these VNets and you're on-prem through ExpressRoute, for example, they're all going to know about each other and route through one to the other, bypassing your firewall. Okay? So this is where your UDR needs to come into play when you say anything coming here has to go to this specific subnet within my VNet. Okay? And same thing to go to on-prem and back to on-prem. Now, by default, please remember that this firewall here, if you want all your traffic to go to the internet through that firewall, you're going to have to establish a default route, a default UDR on this specific VNet, this specific subnet, so that it goes out to the internet.
Which is 0.0.0.0/0.
That's your default route. Okay? So again, that does trip quite a few people when they deploy firewall. Your express route by default will have a BGP that says send everything back to on-prem. Okay? So if you have traffic and you've set up a brand new firewall in there and you did not set up a 0.0.0/0 to go out to the internet, your firewall will send everything back to your on-premises. Okay? So important to say, if you want to use your firewall as a gateway out to the internet, that UDR is critical.
Also, there's the concepts of how Azure does routing. There's an awesome docs article on that as well, which I'll show down the bottom.
Right.
And that talks about the having longest prefix match wins inside, so you can have like routes that are applied to the NIC.
Yep.
And this, for example, is a short prefix, whereas if you had a longer prefix, it would take precedence over that.
That's right. So the basic of routing is this. As a routing device will go through its routing table, it will effectively say, okay, say for example, you've got 0.10.0.0/8 and 10.1.0.0/16 and 10.1.1.0/24. Now, if you want to reach 10.1.1.20, the router will go through its routing table in this manner and go, I've got a route that matches at a higher prefix, therefore I'm going to use whatever route that spews out as.
I guess like in the real world, you could have like one virtual network, for example, with 2 subnets in there, and those 2 subnets each would have a UDR attached to it with that 0.0.0.0/0, any traffic go via the Azure Firewall. However, because those subnets are within the VNet,
that's right.
They've got a default route anyway in them, which is
they will have a route for these through BGP.
For their own each
that's
subnet.
Right. Therefore, they will take precedence.
Go direct.
That's right. That's right. Now, a UDR, if there is a conflict between IPs, because a UDR is considered as a static route, it will take precedence over BGP. So if you have two routes that says 10.1.1.0/24, one being UDR, one being BGP, the UDR will win because it's a static route.
And the other thing too is, like, if you've got two prefixes that are the same, user-defined prefixes take precedence over default prefixes.
Yes, that's right. That's right. That's because they are usually more precise.
And user-defined are UDRs.
UDRs, yeah. That's correct. That's right. All right, let's come back to firewall now.
Yes.
So a few features of the firewall that you can do. You can do DNAT, SNAT, so source and destination netting, so inbound and outbound netting. For those of you who don't know what netting is, we described that in one of our other videos, I think the Express Route one. So go check it out. That's NAT. So you can do in and out NAT on this. Now, you can now assign up to 100 public IP addresses to a firewall appliance within Azure.
Cool.
How good's that?
That's awesome.
100 public IPs.
Jeez.
I mean, that's pretty
Who
good,
would have
right?
that many?
Who would, right? Not me.
Microsoft.
That's right. It's like, who can afford 100 public IP addresses, especially IPv4?
Microsoft.
It's like, okay, so by default, again, this appliance within the platform is highly available, right? We're talking 95.995. If I believe that's right, or 95.95.
Something like that. Lots of nines.
It's lots of nines. It's a 5 at the end. That
Lots
I
of
remember.
nines.
So I think we're talking about 4.5 minutes of downtime per month maximum.
Per month.
Per month.
Per year.
Per month. Per year. Go
Must
check
be
it
per
out.
year.
Calculated. It's 99.9.
It's got to be per year.
Yeah.
Yeah.
It's got to be. That's 45 minutes per year. That's right. It's 4.5 minutes. That's it.
And that's
99.9.
only if.
Only if.
Generally,
That's right.
it'll stay up.
It will stay up. You know, they're very, very commonly matching the 100%. They just put that in so that you're aware that it can go down. Anyway, so only available by default. So compared to those NVAs, you do not need infrastructure. You do not need to pay for a dual D8 or dual D16 to run those firewalls in your environment. You can just deploy it as part of the infrastructure, as part of the platform. Same with the management. So all the management of your firewall is done through the portal or PowerShell or CLI. So this is all integrated within Azure. So all your knowledge of CLI and PowerShell and the portal can just be applied to this. It's the same thing as any other resources within Azure. So you don't need anyone specifically trained on a Palo Alto, Barracuda, whatever it is that you're choosing, right? So as long as you know the concept of firewall and security, you're good to go. That's the idea. So, a couple of more features that we need to talk about very quickly. Threat intelligence detection, you can enable that on the firewall. It will talk to the Azure Threat Intelligence engine, where if a known IP address comes in, try to come in, it'll get blacklisted automatically on your firewall. Fantastic feature. It also integrates with Azure Monitor. So you can monitor all your devices, you can send all your logs to Log Analytics as well if you want to. So this is all integrated as part of the platform. This thing is fantastic. It will keep the bad guys out for you. So
It'll keep the bad guys out.
it will.
So the bad guys trying to get in.
Try to get in, they won't get in with
Are you
you.
sure? They'll definitely
Whoa, disclaimer here. No security system is 100% safe. Always remember that. It's how hard you make it for people to get in that determine a good security system. All right, so very quick recap now before we close up. So Azure Firewall can replace most of the NVAs out there without the need of having IaaS. So you're removing all that IaaS and you make it part of the platform. Hub and spoke. So the idea here is to create a hub network where your firewall and all traffic will go through it, and then pair that with all your spoke networks and your on-premises. Again, IP addresses DNAT, SNAT using up to 100 public IP addresses. You can get in and out of that, of your environment with those. Threat intelligence, I've mentioned that. So you can use that analytics, threat intelligence analytics to actually make sure that the bad guys are kept out. Thank you, Mark. And finally, but surely, all the way to layer 7 application filtering. So you can filter on the FQDN for a website, for example. So that's the best example for layer 7 filtering.
And because cloud years are like dog years, things are happening so quickly in the cloud and Azure, things are coming out all the time.
Yes.
There are good stuff coming. There is good stuff coming.
Can't talk about this, Mark, but there's great
good stuff. There's always good stuff coming.
There's always good stuff. So what you need to do is go and find, there's a great Azure blog feed. I can't remember the URL by heart, but I will put it down there on the video, where you can get all your information. It's a daily feed that comes in with all the new features on Azure. There's good stuff coming for firewalls, so keep yourself up to date.
Or failing that, you can head over to Orlando at the beginning of November and
Ignite.
check out. Yeah.
I'll be there. You'll be there, Mark?
Maybe.
Okay, well, I'll be there, so hook me up when you get there. We can talk at length about all Azure networking related stuff and IaaS. Love the subject, so
perfect.
Please grab me in the hallways and talk to me.
Awesome.
All right.
Thanks, Steph.
Well, thank you very much, Mark. Thanks, everybody. See you later.
Cheers.
Whereby you can centrally manage all your firewalls into one place.
That's helpful. Because you can have multiple Azure firewalls across the globe.
That's exactly right.
Let's face it, we do have more regions than everybody else combined.
Exactly, and everybody wants to centralize these days. So one security team can manage all your firewalls into one place. How good is that? Again,
54
fantastic.
regions. You could potentially have 2 firewalls per region. That's 54 times 2, which is 108. 108.
54 times 2. So it was 52 for some reason. Cut it
That's a lot.
Please.
That's a lot. Azure firewalls.
That's a lot of firewalls, indeed.